Hi, hello and welcome to this media briefing on the MTG-S1 and Copernicus Sentinel-4 missions at the Living Planet Symposium in Vienna. The Meteosat Third Generation Sounder 1 is the first sounder, European sounding satellite in a geostationary orbit, and it will bring a revolution for weather forecasting and climate monitoring in Europe. In addition, the satellite will carry the Copernicus Sentinel-4 mission. And while MTG-S1 and Sentinel-4 are separate, they're also complementary missions, and they're scheduled to launch very soon. In fact, we got today confirmation that the launch date will be no earlier than 1st of July, so it's just around the corner. My name is Nicola Gebers. I'm working at ESA's communication team, and I have the pleasure to present our speakers panel. We have with us today Phil Evans, Director General of Eumetsat, Simonetta Cheli, ESA Director of Earth Observation Programs, Mauro Facchini, Head of Earth Observation Unit at the European Commission, and Florence Rabier from the European Centre for Medium Range Weather Forecasting. All our speakers will give a short presentation, and you will have an opportunity after the last presentation to pose your questions. So I will give now the floor to Phil Evans, Director General of Eumetsat, who will talk about the value and the benefits of the MTG observations for weather prediction and climate.
Okay, well, thanks very much for coming along to this briefing. It's very appreciated. And just to say, before I start, this is an incredibly exciting time for many people. It's obviously a very exciting time for Eumetsat, but ESA, all the industrial organizations that have been working on delivering this, the user community, ECMWF and Met services, this is an incredibly exciting time. So, thank you. Just to set the context for this, really, this satellite, MTG-S1, and actually the whole Meteosat Third Generation satellite program has a wide range of benefits, but its particular focus and impact relates to severe weather events, the sorts of weather events that we've seen in Europe and globally that can have such a terrible impact on society. And this is really the focus of this instrument. So we've already seen the sort of impacts that severe weather can have in Europe. The Central European floods a few years ago, over 200 people lost their lives, financial impact of 40 billion. The Valencia floods, again, over 200 people lost their lives, a similar financial impact. And we've seen the impacts here in Austria last year with the flooding in September, which was particularly disruptive. In fact, the World Economic Forum does a survey with its a membership about what they see as the biggest risk for countries in the coming years, for 2 and 10 years. And severe weather events and the impact of severe weather events are seen as the biggest risk facing most countries over the next 10 years, and the second biggest risk over the next 2 years. And all of this is exacerbated by climate change. Europe had its hottest year ever in 2024. Temperatures are rising twice as fast as the global mean. We've seen in Austria, as well as the flooding, record-breaking temperatures, 2.5 degrees above previous average. And across Europe, over the last 40 years, we've seen economic impacts because of severe weather events of over 500 billion euros. So this satellite addresses a major issue and actually helps societies and communities in Europe respond to these tragedies. And it does this through the 2 instruments that are on board. The infrared sounder, and I'll come back to that in a little bit, and the Copernicus Sentinel-4. And just to note that, I mean, this is the first time that there's been a flight of a combined Eumetsat and European Commission instrument. So it's a landmark in that respect, and it's the first Copernicus instrument that's flown in geostationary orbit, so another landmark. How these instruments help is by providing new and unparalleled sources of data that support services, that support resilience, give us a better understanding of the behavior and dynamics of the atmosphere, support numerical weather prediction and nowcasting. While the Copernicus Sentinel-4 instrument is focused on atmospheric composition, which really means aerosols and pollutants such as NO2 and sulfur dioxide. And the combination of these two instruments gives a real opportunity to provide services that have never been provided before to improve pollution forecasting and other services. So, as I said, this is the IRS instrument is the first sounding instrument from geostationary orbit that Europe's ever had. And when people talk about satellites, I think they're very familiar with the imagery that satellites provide. Sounding missions do something different. They provide a profile through the atmosphere, which means that over time, they provide a four-dimensional picture of the atmosphere, which is hugely important to understand what's going on. Then if you look at the combination, of all of the instruments that are on MTG-S1 and also the other instrument on MTG-I1, which is an imager, plus the atmospheric composition instrument UVN that's funded by the Commission, you've got an unparalleled ability to profile the atmosphere, to see how severe weather events are, to spot severe weather events before they really occur, to see the instability in the atmosphere, to be able to understand where storms are going to arise, to be able to understand when those storms become particularly intense because of the lightning imager that's flying on the other satellite. And coupled with that, a better understanding of pollution and aerosols. It really is a remarkable achievement. And the engineering and technical capability that goes underneath this is an outstanding European achievement from institutions like ESA and Eumetsat, from the European Commission's contribution through to industry. It's a remarkable example of partnership in Europe, which is, I think, something in which we excel. But the end result is better services that will protect property and save lives and help mitigate the terrible events that we too regularly see on television. So thank you very much.
Thank you very much, Phil Evans, Director General of Eumetsat. So our next speaker is Simonetta Cheli, ESA Director of Earth Observation Programs, and she will give us an overview of the European Earth observation landscape.
Thank you. Good afternoon. Could you please put my slide on? Yeah, thanks a lot. So we heard from Phil how this mission is an innovative one in terms of technology advancement, but also in terms of collaboration. And I think that really is what, if we go to the first slide, what really fits into what ESA normally does and what we do both with Eumetsat and with the Commission in terms of providing our expertise to define innovative mission, to demonstrate technologies, to do the first of a series of new meteorological missions. This we do together since 40 years. We do together on quite a number of meteorological missions on which we actually have collaboration with Eumetsat, and we have started in '77. I was just in a session on 50 years of Earth observation, and I mentioned the '77 launch of Meteosat, and we are today at the third generation of those geostationary satellites. And this is really, I would say, the next step of our collaboration, which is a solid one where the user requirements are provided by Eumetsat, but where ESA develops the systems, the space, the satellites, and does it with European industry support, using its expertise in terms of managing those projects, which are often quite challenging. And this is the case for MTG-3. And MTG-3, actually Meteosat Third Generation has 6 satellites in total, is part of this 3 streams. Of course, I said the meteorological collaboration, but we also work with the Commission, and I'm happy to have here, first time ever, as Phil said, a collaboration which is dual, on one side with Eumetsat and on one side with the Commission, because this MTG-S has an instrument on board which is called Sentinel-4, which is the result of a collaboration in the context of Copernicus between ESA and the Commission, where ESA develops the space component of those Copernicus mission with the Sentinels. And last but not least, we have the science missions, and you heard a lot about it in the last 2 days at LPS. If we go to the next slide, we really see what MTG is about. It's 6 satellites overall. It's 2 sounders and 4 imagers. The first images was launched successfully in December 2022. Took a little bit of time due to the challenging technology to actually adjust it, but it's now fully operational. It was announced by Eumetsat. And I think this imager, which is part really of this MTG mission, is helping to have lightning information. And lightning, as the experts tell us, it's really what you need to know if you want to start to forecast better extreme weather events. And MTGS, it's all about nowcasting. Nowcasting, it means improving near real-time, almost real-time meteorological forecast prediction, but it's also about this mission quality of the atmosphere, because we have this Sentinel-4 on board. So it's really a system which, once will be fully in operation, will have 6 satellites, the 4 of imagers and the 2 sounders. It will provide, I would say, long-term perspectives in terms of supporting users with data for the next 20 years. As I said, it's a satellite we launch. It will go in geostationary orbit. It's about 3.8 thousand kilos. It has an initial lifetime planned of 8.5 years, and it's a free-axis stabilized satellite. So the project was managed by the teams in ESTEC, by ESA. As I said, ESA is the one actually developing this program, and I have here some of the colleagues with me today. And it will be, of course, managed in terms of operation by Eumetsat. If we go to the next slide, we see really some facts and figures about Sentinel-4. This is related to atmospheric quality of elements composing the atmosphere. You have every 1 hour an overview of the Earth, and you have it thanks to this spectrometer, the imaging spectrometer, which is on board the mission. You probably know that a lot of people die every year due to air quality. I mean, I think it was Florence who mentioned the 500,000 people yearly in Europe. 7 million people worldwide died due to air quality. So they need to know more about everything that's related to everything that is particles in the atmosphere, concentration of NO2, everything that's related to ozone, which is really what will come from this instrument, is really essential for our daily lives. And if we look at the next slide, I'd like to say that this program is also a program which is excellence in terms of industrial collaboration. In fact, we do have 2 industrial consortia. I see here present the relevant people representing those consortia. For MTG Sounder, it's under the lead of OHB Germany that this consortium was put together with over 200 subcontractors. So you see also the complexity of having all the industrial contribution to the program organized. It involves over 2,000 people, just the part on MTGS, and 15 years to develop. And 15 years to develop because these are really challenging technologies. On the side of Sentinel-4, 15 countries, 50 subcontractors, over 1,000 people involved, and with Airbus Germany in the lead. So you see also the type of collaboration, which I think is a success story of Europe, because through these programs we managed to have contribution at the best and expertise at the best, also in terms of technical expertise, industrial expertise, but also sharing of funds and contribution by member states, because this type of really ambitious programs, I still remember when MTG was approved at ministerial 2008, and it was challenging because it was a pretty, strong investment also for ESA member states to contribute to that. But you see here the results, so in terms of framing that in a context of wider European collaboration. And with that, I would stop, but we have also all the experts on my side and the team in the room, and also the industrial consortia present if you have more questions. Thanks a lot.
Thank you very much, Simonetta. Cheli is a director of Earth observation programs. And next on our panel is Mauro Facchini, the head of the Earth Observation Unit at the European Commission.
Thank you. Thank you very much. And good afternoon to everyone. It's really a pleasure to be with you today. I would repeat, starting with what was said, I think that it's the first time that we have such a combined mission. Actually, we are making the advantage of a Eumetsat mission also to be passengers on board of that, and putting one of our instruments, so Sentinel-4, as it will be Sentinel-5 later, are instruments on board of Eumetsat satellites. I will not go too much into the details, but give a little bit the context in which Sentinel-4 is done. And going to the next slide, please. So Earth observation, first of all, is a very important aspect of space in Europe. We have seen that with a market overview, Earth observation data value-added services can reach 6 billion by 2033. And also the investments of euros in that area can have a return that is almost 4 times. 4 times. And this, I think, is also underestimated in that respect. Where are the distribution of revenue? And here it might be relevant also to what we are discussing today, is not just in obvious areas, but for example, you can also see in climate, in health, in many activities that are extremely important for our citizens. Next slide, please. So Sentinel-4 will be part of the Copernicus program. I imagine that you have heard quite a lot during these days about that. If you didn't, it's meaning that you were not paying attention. But so I think that word is Copernicus considered the world's leading and most advanced Earth observation system. We are not saying that. I think even speaking with our international partners is quite recognized. And again, I think apart us from European Commission, you have here 3 partners, 3 precious partners that we have in that program. It's really a European excellence. So it's really working together with also industry, the member states, and so on. So we have all to be proud as European to have this working. It's a system that is really looking at our planet, generating a lot of data, and with several satellites that are already available, providing different observations. And we had Sentinel, and we still have Sentinel-5P, giving a spectrometer observation, but now with Sentinel-4 and later with Sentinel-5, actually this kind of information will be even higher. Next slide, please. So why Copernicus Sentinel-4? Is really to bring new capabilities, mostly to look into the air quality. So it's looking with the air content, with spectrometers, looking at what is inside there. And this is first reason. And second, why on board of MTG is because, it was already said by Phil, is a geostationary satellite. So for the first time, we will have a Copernicus satellite that is not a polar satellite, but actually is able to acquire data practically every hour. And this is quite important because you don't have to wait every day to know what has been the change of the air composition, but every hour you can really follow what is happening. And this is quite new. This will be later on combined with Sentinel-5, launch actually during summer. That will be a polar one, and the combination of the geostationary and the polar will give also further information. Next slide. What can we observe? Again, I will not detail too much. It's more, I think, for expert. But here you can see some of the atmospheric elements that we can identify: aerosols, nitrogen dioxide, formaldehyde, ozone. That clearly are some elements that are extremely important. I'm sure there are other that I'm not mentioning here, and maybe Florence will have also more details about that. But next slide. Why it's important, and again here I think I will just do that very shortly because again it's related to the Copernicus Atmosphere Monitoring Service. So on one side you have Eumetsat and ESA developers, operators of the satellite, and on my hand right you have actually those that will be using the data to generate the products, and the products is really the Atmosphere Monitoring Service, so the so-called CAMS that will benefit a lot of that in order to better monitor changes in air quality, improving pollution forecast, providing faster warnings, and so on, and having these kind of maps that are not just beautiful but have really some sense to the user communities. Next slide. Why the European Commission is investing in that? We don't have a long history on space. Actually, we started to get, because I mean, after 20 years, I think we start to get some experience into that, but we are among the four of us, the last newcomers. It's not because we were really fond of space, we want to do space for space. We want to do space for the citizens, and space for the citizens is many products that are useful to everyday's life and also to EU policies. And indeed, there are a lot of pieces of legislation and more that are related to the Green Deal, to the quality, to the well-being of citizens, and to the health of that. And so, just here you have a couple of them: Zero Pollution Action Plan and EU Ambient Air Directive. And for sure, this kind of information could be useful on one side to better understand the world we are living in, and the second, if measures are put in place, how effective they are, and these instruments will help us in this respect. Next slide. And indeed, I mean, this is also possible for companies to use this data, and for everyone. So we have a Copernicus Space Data Ecosystem where you can actually, is a platform where you can download for free all those data. You have a support office where you can get information about what we do. We have also some initiatives in support of small and medium enterprise, all the downstream sector, either to have some financing or also some input for research. And next, yes, we can skip this because it's it's an outlook of Copernicus what it is. But here, as I said, today we're speaking about Sentinel-4. This summer will be Sentinel-5. And actually in the next years, and we are already working on that, another satellite that will be extremely important for air monitoring quality will be CO2M, so that we will look at the anthropogenic emissions of CO2. And today we are working quite a lot in order to ensure in the next 7 years, 2028, 2035, that actually sufficient funding will be available in order to make that sustainable in the long term. Thank you very much.
Thank you very much, Mauro Facchini, Head of the Earth Observation Unit at the European Commission. And our last speaker on the panel is Florence Rabier from the European Centre for Medium Range Weather Forecasting, and she will indeed explain us more about the user perspective.
Okay, so yes, I'm the Director General of ECMWF. We are an intergovernmental organization doing global modeling. So global prediction of the weather for the next few days and few weeks ahead. But we also have similar member states as Eumetsat. So we work very closely with the Met services who actually themselves look at more regional, national weather forecasting. So I will talk a bit about both. So to put it in the context, of course, we are extremely excited about this new MTG sounder, but we also had the operational MTG imager. So really this is going from success to success for the European landscape of satellite. And the imager also with this advanced imager, but also the lightning imager, we could already use more instruments to see what severe weather is coming. So, but the sounder, of course, adds another dimension, and it's in particular the vertical and temporal dimension. So to go back to our experience with using satellite for weather forecasting, we've had experience for decades at ECMWF, but really we know that on average we use more than 95% of the data we use come from satellite, but numbers, it's okay. I mean, you know, they could be a 95% of data, but not very relevant. But we also know that the quality of our forecast is very much driven by these data. This is an example where to document the quality of the impact of satellite data on forecast quality, we actually removed for a couple of weeks satellite data from the input to our system. So you have two equivalent forecasts here. On the left, you have the one using all the data, and on the right, you have the one where we removed for a while satellite information, satellite data. So this is from a few years ago. There was not yet MTG, of course, but there was already, for instance, YASI. So there was already these hyperspectral sounder, which are so important to document the initial starting point of the forecast. what you can see is that when you don't use satellite observations, you don't see the same, yeah, it seems that one is not playing anymore. Yeah, this one is not playing anymore. Hopefully you had seen it before. Yeah. Anyway, you could see a small disturbance coming out from Africa there. Sometimes these hurricanes that are really strong developing and affecting a lot the Caribbean and the US, they start from small disturbances off the coast of Africa that don't look like much, but then somehow they get enhanced over the Atlantic if you have the right conditions. And then, yeah, so you can see these little things going on over the Atlantic. It was coming from Africa, it develops. In one case, it just sort of vanishes. In the other one, it gathers strength over the warm oceans, and it starts rotating madly and affecting the Caribbean and then affecting the USA. This was one of the most devastating hurricanes in 2017. So in some places, 50% in Bermuda, was it Bermuda? Yeah. No, it's not Bermuda, Barbuda, sorry. 50% of the people became homeless, so basically it was flattened out. So this is because now we can use the satellite data, we can have an impact from them. And hyperspectral sounders, what is great is that they have a lot of frequencies which allow us to have a fine vertical resolution. So we don't just see a broad image of the atmosphere, we can see really a fine level of temperature and humidity in the vertical. And this allows us to much better actually see what's going on and then predict the weather. So I've talked about global weather there, but really having, okay, let's talk about atmospheric composition. I'll come back to what I wanted to say about the weather. This is an example of what we're running for Copernicus Atmosphere Monitoring Service. If you could play again. It's okay, it's a nice picture, it's also a nice video. This was an example, yeah, a couple of weeks ago when we actually had both aerosols coming from the wildfires in Canada, which were very, very devastating over there and affected for atmospheric composition quality, air quality. But they didn't stay over Canada or the US. They actually came all the way down through the Atlantic. At the same time, you had this air coming up from Africa and you had this desert dust coming. So the combination of the two was really quite a lot of aerosols over Europe, which can be quite dangerous for health, which can also affect actually the production of solar panels. So if you can predict those earlier in time, then you can warn populations that it's actually quite dangerous. For instance, ozone levels can be high as well when you have heat waves. And you can also warn people who are operating solar panel that they should actually plan for actually cleaning their panels, because you will have dust going onto it and affecting their power outage. So this is what we can do now. So how will MTG help? So as I said, hyperspectral really brought a lot of things. With YASI, we had experience with EPS since 2006, and very, very beneficial. But then having it geostationary, again, we can have it at it was said, at a high temporal resolution as well. So you can see it happening much faster, and you can see the whole diurnal cycle. Then I'm thinking more about what happens over Europe. And in the Mediterranean, sometimes you have what we call medicane, for instance. So what's that term, medicane? It's medicane hurricane, Mediterranean hurricanes. It's a sort of combination. It's some of these very strong storms that develop over the Mediterranean, and there you don't have other observations than satellite. The radars don't come all to there. And sometimes they have explosive developments. We had some dramatic events a few times over Italy. It also struck Corsica. So these medicanes, you can see them coming, but then sometimes they just develop super fast. So having them at a high resolution every hour, it's very important. Also, of course, Meteosat will help also over Africa, and so it's not just over Europe, even if member states of Eumetsat and ECMWF, of course, are over Europe, but we also work with Africa, and as you know, there are a lot of extreme weather over there as well. For atmospheric composition, it will see other things as well. Very excited about Sentinel-4. And Mauro said it will allow us to see the diurnal cycle of these components. And this is very important to observe, but also to better understand the play between the chemistry, the physics, the emissions. And if we can better understand, we can better model, we can better forecast. So I think this will be a game changer in our field, both for global modeling and of course for regional modeling over the whole area covered by MTG. The last thing I want to say is that I think it couldn't have come at a better time, because now we also have the technology in weather forecasting and using observations with AI machine learning, where we can actually, and this is the one where we can actually use observations much more fully than what we did before. This is just a simulation of using artificial intelligence with only observations to produce weather forecasts for the next days. And this is something we wouldn't have dreamt of doing a couple of years ago. In practice, we are still combining our model with observations, but we can see the potential of actually starting from observations and doing a whole weather forecast. And when we combine all that, this means that when we are a bit limited in our process of assimilating data at the moment, where we can't use certain types of observations or the whole resolution of observations, AI can probably help us to make the most of these new observations, to really use the wealth of data and for the best of weather forecasting, as Phil said, to protect life and property, which is our joint duty.
Thank you very much, Florence Rabier from the European Center for Medium Range Weather Forecasting. Now we have time for your questions, actually from within the room, but we also have media colleagues following us online. They can also post a question in the chat. We also have additional representatives from industry in the room, from Eumetsat and from ESA. And thank you very much, Giorgio Bagnasco. He's a Sentinel-4 project manager from ESA, joining us here on the panel because Simonetta Cheli unfortunately had to leave a bit earlier due to another commitment. So please state your name and your affiliation before your question. And my colleague Carmen has the microphone for you.
Hello, Thorsten Greening, Spacewatch Global. Thank you very much for this panel and these interesting insights. I have a question for Philip, Mauro, as this conference states from policies or from measurements to actions. We saw that MTG has the potential for executing something new. What will be the concrete action plan that we do with the data for all of us here in Europe? So that's potentially more a policy question.
Well, if I could perhaps speak from the perspective of the meteorological community, and Mauro could maybe add something on the policy elements. I think what is important to understand is the community of the meteorological community provides a huge amount of value and impact to societies. But that comes about through a really complicated ecosystem of players. From one end, from organizations like Eumetsat, supported by ESA, and also the work the Commission that does, that provides observations, the exploitation of those observations into services, the delivery of those services to decision makers, and in the case of severe weather events, that's first responders very often. Those services are delivered, and then those first responders have to make decisions in the light of that information. So it's a complicated chain. And actually, what really matters is the end users, the first responders, the decisions they make, how they manage severe weather events, and that's down to them. But what this does is basically provide better forecasts and warnings, higher quality with more lead time. And there is abundant evidence that with better lead time, better warnings, these massive impacts of severe weather events are reduced, and even quite small.
But can you qualify that as well? So are we talking about hours, days?
For something like this, we would potentially hope for hours of improvement, because this is very much focused on nowcasting, which is very short period forecasting. But it depends. It depends on the weather event. It depends on the location. Depends whether it's flooding or wind or whatever. But it's of that sort of scale, and that can make a really significant difference.
Yeah, I think that at the end of the day, is the citizens for us is the target, really, to try to understand what they can get out of that. So the satellite data are quite important, I have to say, but at the end of the day, what we need are the final products. So, and at this, we'll have to satisfy the user requirements. And through that, at least, first thing, we'll have the monitoring of what's happening. So we'll better know what's happening, what is in our atmosphere. And this can tell us is good, is bad, or also to put in place some measures that could simply say to people that have some health issues, please, that they don't go out. They can have even some applications where actually in your place they can tell you, today is not good to go out, and these sort of things. So second is, if you see that this is happening, what kind of action we can do that? And there we have legislation that actually can say we have to reduce amounts of emissions, this on that direction, and so on. But once this is done, is also to monitor. So to check if this is really done. So really to check all the parts. So check the situation, action, and then monitor. And all this cycle to be done, knowing that at the end of the day, actually who has to benefit is the citizen in some way. And we believe that with this data that are quite new, they will get more and more information. Sometimes it's also surprising that you launch satellites, but I think my friends here know that more better than I do, without knowing what you get after. So in the end, you get much more than what you have thought when you launch that. But I don't know.
Yeah, no.
Say we will get better weather forecasting based on the MTG.
For the weather forecasting, I think is more business, I have to say, for Phil, because I mean, from our side, I have to say, Copernicus is everything, a lot of things, but not meteorology. Meteorology, I think, is really in the realm of Eumetsat and ECMWF. For what concern Sentinel-4, so air quality and so on, for sure we'll get much more than what we have today. More information, more frequent new products and so on. So there will be indeed an improvement. Quantifying that, it's difficult now, but we'll see.
Yes, we'll get better forecasts, we'll get better warnings, and there are other services that use satellite data, and they'll be improved because of this.
Thank you. We have another question in the back. No? Do we have an additional question from our audience here? Then we also don't have questions from our online audience. Then there's one still.
Hi, I'm Olat for EFE Press Agency. I would like to ask if you could talk a bit more about the use of AI in Sentinel-4.
I think that would be for Florence. Yeah.
Okay, yes, we are actually just starting using AI and machine learning for atmospheric composition. We've actually started using it more for weather predictions, for temperature and humidity, etc. But we can see the potential for Sentinel-4 as well. And actually, there has been some precursor work combining as well, having a whole, what we call a foundation model that predicts the whole Earth system with both weather parameters, temperature, humidity, winds, and also atmospheric composition. So we are really having research in that area, and I'm pretty sure that we will, we had a very first preliminary result, so I mean, it's not published yet, so, you know, but it's promising, and I'm pretty sure that we will combine it. But what's important to know is that this whole understanding from the physics and the chemistry will stay with us. So AI on its own will not do everything. It will be combined with all the knowledge that we had already about how the Earth system is behaving.
Thank you, Florence. Do we have any additional questions? You have one more, Torsten?
I can do it for a living, you know. It is actually a question for Simonetta, so potentially you will take that then. In her slide, it showed MTG-S1 in the time range of 23, 24. Now we have, at least according to my calendar, 25 already. So is the project shifted to the right, and does it have an impact to follow-up missions? And what is the impact the US cuts of NASA or wherever have potentially on those projects? If not, fine. If yes, what would it be?
I start from the end. Impact of NASA cut of budget on Sentinel-4, none. So, as you might know, the idea is that the first model, the PFM of Sentinel-4, will work for 8.5 years. And after that, the second model, which we are, as we speak, calibrating in RAL, UK, will be put in what we call long-term storage, so that in 8 or 9 years, we can launch MTG-S2 with the Sentinel-4B. The idea, as it was being highlighted multiple times throughout all these days, is continuity of data. So we want to monitor the quality of air throughout not 1 or 2 years, but through decades. So this is the strategy that has always been there. As far as the second part of the question, if you can help me.
With the second part already, so
okay, then
okay. So the project is on track. Also, the other MTGs are on track.
Absolutely.
Additional question on that: the end of life management. Will it be according to the zero debris charter of ESA, or what model for end of life are you applying here? Just graveyard orbit, or?
I have to say that, of course, this is more a question related to the satellite. I don't know if maybe the colleague from OHB would like to reply to this.
Hey, yeah.
Maybe you could hand the microphone over, please, so the colleagues online can also listen.
Okay, yeah. So from geostationary orbit, we will go into a graveyard orbit with all the satellites, yeah. So this is all in line with long-term requirements that started in 2008, as Simonetta mentioned, for MTG.
So if I may, just to add a couple of things to that point first, and then about the impact of some of the policy changes in the US. So yes, similarly to what we've done with the previous generation of geostationary satellites, at the end of their life, we put them into a graveyard orbit, and in fact, they tend to last a very long time. So Meteosat 8 operated for 20 years. And then was put into a graveyard orbit. I just wanted to add a little bit to your comment about NASA. From Eumetsat's perspective, collaborations with the US are very important, but our relationship is with NOAA. We have a relationship with NASA, but the operational relationship is with NOAA. And that's a very important relationship. It's very important to Europe, and it's also very important to the US. Clearly they are working through the implications of some decisions, but I'm pleased to say that for us, that relationship is continuing and the cooperation is continuing because there's mutual benefit in it.
Thank you very much. So before we conclude this media briefing, I'm just looking quickly over to my colleagues. They give me a thumb up. I would like to hand over quickly to one last speaker, an ESA colleague, Mr. James Champion, who is a ESA MTG-S1 project manager, and he's already on the launch site at Cape Canaveral, and maybe he can give us a quick update on how things are going there.
Okay, can you hear me?
Yes.
Yes, thank you very much. Yes, here behind me, you can see the current status of the satellite. We've just, in fact, moved it about half an hour ago from one of the stands that was used for the propellant loading, and now we're mated on the first interface with the rocket. And then over the coming days, we're going to mate onto the next interface with the rocket. And then finally, the encapsulation on Thursday will take place. And then the rollout of the encapsulated assembly from here, from the Astrotech clean room facility, will take place. And on Friday, we will do the transport to the launch pad and start the integration onto the rocket, getting ready for the launch, which was previously confirmed as being on the 1st of July as the first attempt, which is excellent news. Excuse me. So everything's nominal, everything's running smoothly, and we're looking forward very much to the next phase, which is the launch, coming up next Tuesday. Thank you.
Thank you very much, James Champion, ESA MTG-S1 project manager from Cape Canaveral. Of course, we all cross our fingers for the launch, and thank you very much here to our audience for your interest, for your questions. Thank you to our online audience for following us. Thank you to our speakers today, and please follow us online on the different website of our different institutions to get any updates on MTG-S1 and the Copernicus Sentinel-4. And we conclude hereby this media briefing, and I wish you all a very nice day and a successful symposium.